Uday Kishore. Uday Kishore.
Uday Kishore.
Yes, ma'am. Good morning, ma'am.
Good morning. Please start.
Okay, ma'am. Good morning to all. A warm welcome to the members of the faculty, to the guest of honor, and my dear participants. When wealth is lost, nothing is lost. When health is lost, something is lost. It is no coincidence that 4 of the 6 letters of health is heal. This webinar on IoT in healthcare systems has been painstakingly planned by the Department of Computer Science, SRM Ramapuram campus, for the betterment of the student populace. This has been organized with the sole purpose to enrich our knowledge on healthcare systems.
We will now have Tamil Thai Vaalthu, the invocation to Tamil.
நீராறும் கடலுடுத்த நிலமடந்தை கெழிலொழுகும் சீராறும் மதனமென திகழ்வரத கண்டனிதில் எக்கணமும் அதில் சிறந்த திராவிடனல் திருநாடும் தக்க சிறு திரை நுதலும் தரித்தனரும் திலகமுமே அத்திலக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் மணக்க இருந்த பெரும் தமிழனங்கே தமிழனங்கே உன் சீரிழமை திறம்பியந்து செயல் மறந்து வாழ்த்துதுமே வாழ்த்துதுமே வாழ்த்துதுமே.
Darkness cannot drive out darkness, only light can. Hate cannot drive out hate, only love can. We shall now have the lighting of Kuthuvalakku.
Small cheer and a great welcome make a merry feast. May I now invite Dr. S. Umarani, Professor and Head of the Department of Computer Science, BSc, to propose the welcome address.
Good morning, our honorable guest, Mr. Abhishek, participant, staff and student. It is an honor for me to welcome you all here. SRM Institute of Science and Technology is one of the top ranking universities in India with over 20,000 students and 1,500 faculties, offering a wide range of undergraduate, postgraduate and doctoral programs in engineering, Management, Medicine and Health Sciences, Science and Humanities. The Department of BSc Computer Science, SRM Ramapuram, was established in the year 2015 with the objective of imparting quality education in the field of computer science. BSc Computer Science is an undergraduate course that includes all the aspects of computer science and related subjects that are necessary to make a career in the software industry. It is a 3-year program and has been specifically designed for aspirants looking for a career in computers. The course covers all aspects of computers, right from the basic fundamentals of computer to database system, and advanced courses like Python, Java, AngularJS, artificial intelligence, Android, big data ecosystem, data science, cloud computing, IoT, etc. The course curriculum and structure is made in such a way that the skills and knowledge received enable students to apply their career. There are many allied companies like Google, Amazon, HCL, Wipro, TCS, Capgemini, Tech Mahindra, etc., where BSc Computer Science degree holder can hunt job opportunity. The department currently consists of 16 faculty members, approximately 570 undergraduate students, and 2 research scholars. In the effective teaching learning process, we have signed 3 MOU with the leading company like Unanu Technology, Inspire Software Solutions, and published 2 patents, 1 consultancy project, and launched various applications in Google Play Store. One of the popular applications is used by the student in the regular basis for the academic purpose. The department has modern facility for teaching, learning, placement, and research. It offers a wide array of research opportunity and program of study at undergraduate level, and also provide co and extracurricular activity to the student. Besides this, the department offers Doctor of Philosophy, PhD in Computer Science. With rapidly evolving technology and the continuous need for innovation, the department has produced quality professionals holding important position in the industry in India and abroad. The department has various club activity for identifying hidden talent from the student, which helps to crack the interview process. Top companies are visited every year. We have excellent placement record and almost 90% of students have been placed in top companies. We have 2 university rank produced by the department in every year. This is a small intro about college and department. The Department of Computer Science, BSc, has organized one-day webinar on IoT in healthcare system. The webinar is very much useful for research scholar, final year UG and PG student, and those who have equipped the knowledge in the field of big data, IoT, and cloud. We found that today webinar topic are appropriate for the current scenario of learning. We all have assembled here today to motivate and cherish the young minds present within us. Apart from it, this is a great occasion to welcome our chief guest of the today. I am profoundly delighted to take an opportunity to welcome the chief guest of the day, Mr. Abhishek, AI Principal Scientist, Accenture Operations, Bangalore. In spite of his heavy schedule, he accepted to grace today's function. I am really happy to welcome him. And also, we welcome our beloved participant, staff, and students. Once again, welcome you all. Thank you.
Thank you, ma'am. Happiness is the greatest form of health. May I now request Mrs. T. Kanimori, Assistant Professor, Department of Computer Science, to introduce the guest of honor to the participants in the platform.
Good morning, everyone. It's my privilege to share the profile of our chief guest, Mr. Abhishek Gunjan, AI Principal Scientist, Accenture Operations, Bangalore. Mr. Abhishek Gunjan has around 16 years of experience in analytics, team building, bringing new business, and end-to-end delivery. Previously, he had worked with multiple organizations such as Associate Consultant in Wipro Limited, Bangalore, also as Module Lead in Impetus Infotech India Private Limited, Indore, Madhya Pradesh. He had worked as a Senior Software Engineer R&D in Zycus Infotech Private Limited, Mumbai. He has also worked as Senior Software Engineer in Vista Technologies, Mumbai, and many more. He has various technical skills in machine learning and natural language processing, core Java, R, SQL, NoSQL, ELK stack, and Python. He has completed his bachelor's degree in computer science at PES College of Engineering, Mandya, Karnataka. MS in system software at BITS Pilani, Rajasthan. And he is currently pursuing PhD in Christ deemed to be University, Bangalore. Apart from this, he has built multiple algorithms and worked with multiple professors in IIT Kharagpur, Indian Statistical Institute, Kolkata, IIT, Powai, and Open University, UK in areas like summarization, classification, and topic modeling. Our chief guest also has experience in banking, insurance, media and research, healthcare, telecom and finance, and accounting domains. He has published 12 patents with 6 grants in personality prediction, big data design, recommendation engine for insurance and healthcare, continuous accounting, and close, clinical research, classification framework, etc. Thank you for this opportunity. I welcome you, sir.
Thank you.
Thank you, ma'am. Mahatma Gandhi once said, "It is health that is the real wealth, not pieces of gold or silver." May I now cordially invite and welcome our honorable chief guest to address the participants of the session.
Sure. Thank you. Am I audible to all?
Yes, sir. Yes, sir.
Great. Let me share my screen. Okay. Thank you everyone for inviting me and giving this opportunity to come and talk to the students on this. And thank you very much for a very good introduction. Right. Let me take you through the recent research that is being done in Internet of Things in healthcare. And let me, yeah. Just give me a sec. Okay. So, yeah. Give me a sec. I'm trying to. Okay. Hope this is visible now. So today's agenda would be to know more about what is Internet of Things, especially in healthcare. And then I'll walk through a quick introduction about the usage of IoT in healthcare. And then we'll move into the different sensors and which are used in IoT. And then we'll touch upon the IoT in healthcare, especially. And then we'll look at some of the use cases, which I have personally used in my real life. And then we'll touch upon things like analytics, big data, right? And then we'll get into a brainstorming session where we would invite all the participants to come and place their look at the data and analyze and say what can be done. Then we'll also look at the latest research which are happening in this area, and then we'll get into some references and questions, right? So this is how I have typically organized today's session. So as a thumb rule before we start, I would like this session to be very interactive. You can put your messages on the chat. So the first objective for this session would be that we want to have it as a brainstorming session where we can come up with innovative ideas, right? Not necessarily that it should be a working prototype, but we can certainly bring in something new on the table, right? We can start with something like state of the art, see what is happening in the current world, how it can be used in our day-to-day life. And I would also encourage students to pick up the areas of interest, right? I have one of my another friend who is who has done his PhD and has picked up certain areas of interest where we want to see how IoT can be brought to the industry and how can it be brought it to the end user. I would also encourage everybody to take part into the session. This is an online session, so I cannot call out the names, but you can certainly put your messages on the chat, right? And a feedback at the end of the session would be certainly appreciated, right? So this is how we would organize the session. And these are the thumb rules for the session, okay? In between, if you want to ask any question, you can also unmute yourself and you can always ask, okay? Now, before we start this session, right, I always personally feel that innovation is all about finding answers to relevant questions, right? Whether it is IoT, whether it is AI, it is any other field. In fact, the research is all about finding answers to relevant questions, right? So let's start the session with that thing in our mind, okay? Now let's try to understand more about IoT. You guys can use a chat window and you can post, what do you know about IoT? Just keep a couple of seconds and we can post your thoughts here. Let me see, where is the chat? Just take a pause for a minute and then you can post your messages here. Is anybody typing? I don't see anything in the chat. Ma'am, I would be able to see the chats here, no? In the chat window. Am I audible?
Yes, sir. Yes, sir.
Yeah. I would be able to see the questions here in the chat window, right?
Yes, sir.
Okay. Anybody, what do you know about IoT? Any random thought is fine. There's nothing right and wrong here. Connecting physical objects via network. Very good. What else? Anybody else? Working with sensor. Very good. Yes, that's true. Thank you, Harshini. Thank you there. What else? Any idea why do we need IoT? Used for real-time problem. Yeah, Sita, that's good. Yes, we'll look at real-time problems today. Devices and machines are connected with each other and the internet. Very good. Yes, that's right, Syed. You can share the message to all the participants. That's fine. Everyone who is there in the meeting. Any idea why we need IoT nowadays? Can you think of an example, maybe related to COVID, related to, diabetes, to cardiac arrest? Okay. Good. Effective monitoring. Yes, that's right, Harshini. Effective monitoring in ICU can be one of a very good use case. How many of you know what is the proportion of doctor to patient ratio in India, in rural India and in urban India? So it has been said that 25% of the country's population live in cities, right? Which has around 75% of all the hospitals. Whereas for 75% of the population, we have only 25% of the hospitals available, right? And that's where there's a big gap. This is one of the area where IoT can certainly help. And there was a very beautiful use case long back where there was a surgery that was performed in Arunachal Pradesh. It's an eastern state of India. And we did not had right doctors available at that point of a time, and there was a cardiac surgery. And there was a doctor sitting here in Bangalore, Dr. Devi Shetty, who was facilitating a doctor out there in Arunachal Pradesh using a video conferencing. And then that's how the surgery was done in Arunachal Pradesh. So that's one of the way where you can use a video conferencing, but it's not an IoT based example. IoT is all about sensors. It's about monitoring the patients using the sensor. It is about taking a proactive actions, or it can also be taking any action on the data which is already captured. Now, having said that, let me move on to the next slide. What is Internet of Things, right? So going with the bookish definition, the Internet of Things is a system of interrelated computing devices, mechanical and digital machines, objects, animals, or people that are provided with unique identifiers and the ability to transfer data over a network without requiring human to human or human to computer interaction. The example that I just talked about Dr. Devi Shetty, here there is a person who is sitting. So there is the data or the knowledge that is getting transferred from human to human, whereas in IoT, the data is not transferred between human to human, right? So without requiring human to human or a human to computer interaction. So it's a computer to computer kind of an interaction. And then we have automated modules which analyze the data, and then it triggers certain actions and so on. Okay, so this is the definition, but what it actually means is taking all your physical devices, places, and the things in the world and connect them to an internet. This is what an IoT is in short, in simple layman terms, right? You just take all the physical devices and connect them through internet. And that is where the upcoming technologies like 5G would play a very vital role, where the data can be transferred very fast, right? One of the important quality of IoT devices is you can capture data on a continuous basis. Just take an example of a heart monitoring or take an example of ECG, right? When you go to the hospital, there is a 7 diode based ECG device that is typically used to take out your ECG. Now, those are very bulky devices. There are certain advantages. Certainly, it captures your ECG a lot more accurate. But one of the disadvantages is you cannot capture it on a regular basis, on a continuous basis. And that is where there are certain devices which are like three diode based. The one that I used was a 3 diode based, where you can continuously monitor the heart rate of a patient. And I would talk about the use cases where we have saved many lives of patients by using those devices, right? So this is what an Internet of Things is, if you have to define. I would also say in today's world, like Dr. Michio Kaku says that, electricity is something which is everywhere and nowhere. This is what is going to happen to IoT in future. It is something which is everywhere and nowhere. It is there in your watches. It is there in the necklace that you're wearing. It is there in your bracelet. It is everywhere and it's nowhere. It is there in your shoes, everywhere, right? That's how it is going to become in future. Right? Now, let's look at a background. As I said, there are Internet of People, where people are connected with the internet. In case of IoT, the devices are connected through internet, right? Whether it is a traffic control device, or there are sensors which are being put into plants, or Fitbit devices. So all of these devices are connected with internet. And you would have seen the advertisements from Wipro Lighting, where the husband is sitting in a office, and then he noticed that his wife is asleep, and then he dims the light or switches off the light over the internet, right? Now, these things can also be done automatically. In nowadays, if you look at the new apartments that are coming up, the way you walk, if there are people available, the lights would start and it would dim or it will switch off if people are not there. Now, those are typically done by using an IR sensor, and we'll talk about it. Right? So this is what, in short, is IoT. Okay. Now, how does the IoT devices communicate? So now we know what are IoT. Now, the important thing now to look at is how do these devices communicate with each other? Now, there are different types of technologies that are being used. The first one is by using a Bluetooth. We all know that it's a short range IoT communication protocol, right? And it can be used in transferring data through a smartwatches, your fitness devices, and so on, right? Then there's a next type of protocol, which is called as Zigbee. It is very similar to Bluetooth, but it consumes less power. It has got a high security and it is more robust. So it can be used in things like street lights, your electric meters, and so on, right? The third type is called as a Z-Waves, which is again low power radio frequency based communication technology. Okay. And it is designed for things like smart home networks and devices and so on. Then Wi-Fi, again, it's a very largely used protocol where the transfer or the communication happens through the Wi-Fi network. Then we have a cellular based communication. Nowadays we use less. There's an example where I had used a cellular based technology to transfer the fetal heart rate in villages in India. So I was working in a company where we had a IoT device which can be placed on the pregnant lady's body, and it continuously monitors the baby's heart rate. Okay, this is typically used in some of the hospital. I think it's still used in hospitals here in Bangalore, where we monitor the fetal heart rate on a real time. And it's typically used in a very high risk pregnancy cases. So there we were transferring data on 2G based devices, right? So in villages, you don't have that kind of a bandwidth. So that's another type of communication protocol. Then we have NFC based protocol. It's nothing but a near field communication, which enables simple and a safe communication between devices which are within 20 centimeters, something of that sort. So it's a near field based communication. So you can imagine healthcare devices where you are monitoring the oxygen level, you're monitoring the heart rate, so capturing the vitals, and then you have a computer there where all of the information gets transferred real time. So those are like based on NFC. Then you again have another type of communication called as low range WAN wireless area network, right? It's again is a non-cellular based. It's devices or communication channel which are used in smart cities, industrial applications, and so on. So it uses a RF based communication protocol, right? Any questions so far on this? We're good to move. Okay, let me move to the next slide. Now, coming down, now we have looked at how it can be communicated. Now, what are the different modes of communication? Now, communication can happen through an HTTP protocol. It's a CoAP based or a WebSocket, or it's a message based protocol, right? Or it can be a data distribution based protocol. Okay, there are some protocols which are based on a queuing mechanism. So let's look at HTTP. It's very popular. We all know it's a TCP based protocol, which we use in all the website HTTP, HTTPS. So that's another way of communication. The second one is a constraint application protocol. This is UDP based protocol. The third one is a WebSocket that we all know. There's a transport layer. You can open a particular socket and then you can transfer the data, right? The another one is based on a messaging based technology. So MQTT is another message queue telemetric transport. Then we have a XMPP, which is again is a messaging based protocol. It is used in sensors like water heater, electric meters, and so on. And long back, I was working with some of the devices like printers and so on. There we had used XMPP and SMPP based protocols to capture data and analyze it. Right? Then there are different data distribution based communication mode that are available. Then there are advanced message queue based protocol. And now this is very important. The message queue protocol is required because these devices can continuously push data. It is based on a push and a pull based mechanism, whereas your system might not be able to analyze all the packet at the same point of time. Just take an example of SPO2 device. The SPO2 devices, some of them that you use, it broadcasts and sends a lot of information. It keeps on broadcasting it. Okay. And we had encrypted or we had analyzed that packet. So they pass the information in a middle. It's a long queue of information. In the middle, they pass the sp2 oxygen level information. Now, these devices continuously sense the data. Now, you cannot analyze it at times. You might have to analyze in a certain interval of time. So that's where you need a messaging queue-based protocol. Okay, that's where AMQP can be used. Now, we can go in. Any questions? Okay. Now we can go in detail about these communication protocols. Some of them you already know, like HTTP. We have seen it's stateless, and it supports method like get, post, put, and delete method. And it's a browser-based application running on the client. Then CoAP is typically used from machine to machine. So if a communication is happening from a Fitbit devices to that of your mobile phone, then it uses some kind of a CoAP based communication mode. Then it again is like it has similar kind of a method like HTTP. It has a get method, put method, post, and a delete method, right? WebSocket, we saw it. It is based on again TCP. It's a full duplex communication over single socket connection, and this is typically used in a lot of IoT devices. Okay. Then we have a message queue based protocol communication, which is based on publisher subscription model. So these devices will keep on publishing the information. If you subscribe to it, then you will be able to capture those packets. So there is a message queue broker that is typically used in these communication mode. Okay. And you can use this where you have memory and resource constraint. Okay. Then XMPP protocol we talked about. It's a real-time communication and streaming XML data between network and elements. This is suitable for voice and video chat, message, data syndicates, gaming, multi-party chats, and so on. DDS is again a middleware for device to device or machine to machine transfer of data. It's again based on publish and subscribe model. So they keep on publishing the information. If you subscribe to it, then you'll be able to listen, right? It is something like you have a Fitbit device, and if you have not registered to your mobile phone, then it will keep on, publishing the data, but you will not be able to capture them, right? Then the last one is on your message queue, which is used for business messaging, right? It is again based on message is pushed by the broker and it is pulled by the consumer. So in short, if you look at it, all of these communication models, there are majorly 4 types of communication model. The first one is a client server based model, right? The HTTP one that we looked at, those are client server based model. The second one is a publisher subscription model, where the devices keeps on publishing the data, and there is a subscriber which subscribes to it and then analyze the data. The third one is based on a push and a pull model, and the fourth one is an exclusive pairing, right, where your device is only paired with a mobile phone. Even if there are other mobile phone in the same range, they will not be able to get the data because you have done exclusive pairing, right? So these are the 4 different communication mode that are being used in IoT. Any questions so far? Let's take a pause for a while. Any questions on this? You can use a chat window. Okay. So I'll go through a couple of slides which are more on theory, You need to understand the foundation, and then we'll move on to the use cases and the recent research. Okay, so let's move on then. Now let's look at what are the key sensors that are used in IoT, not necessarily a healthcare, but in IoT. Okay, so these are different types of sensors. Now, the one that we see here on the left, you have a heartbeat sensor. So the example that I talked about, fetal monitoring, these are all heartbeat based sensor, which monitors your heart rate on a regular basis, right? Then you have IR sensors, which are based on different types of technology, like it could be a reflective type of a technology, or it could be a transmissive type of technology. So the lighting examples that you see when you're walking, the light will switch on and switch off. Those are based on IR based sensors. You can also have an IR sensor in an AC, right? Where if there are more people, then based on that, the blower speed can be monitored or can be changed. Then we have rain sensors, which are available. Then we have other types of temperature sensors. Then there are color sensors. Now, how do we use these sensors? Typically, if you look at some of the things like in dermatologist in healthcare, we use the color sensor to detect the cancer level in the skin. So based on the changing color, you can find whether the skin cancer is there or not. So that can be done by using a color sensor. Alcohol sensors, we all know this, right? Then we have a gas sensor. Within gas sensor also, you have multiple types of gas sensors, right? Typically in mines, gas sensors are very popularly used, where they check whether there is a methane present or not. So there are sensors which can capture the methane, presence of methane, presence of chlorine. So those things are done by using a gas sensor. We have a smoke sensors also available, which are very popularly used in buildings now. If there is a smoke, then it will raise an alarm, or it will start, it will start raining or something like that. So that's where the smoke sensors are used. Then you have light sensors. Then you have water flow sensors, which can monitor what is the flow of water, right? On the similar line, we also have petrol monitoring level sensors, which looks at if the petrol has reached a particular level, then it would trigger that the tank is already full. There are humidity sensors, which monitors the level of humidity which is present. And then there are different soil sensors which are used. Typically, if you look at IoT in agriculture, there are a lot of soil moisture sensor that are being used. And based on that, you can now decide whether you need to, whether the irrigation is required or not, whether you need to put water in the plants or not, right? So those are done by using soil moisture sensor. Okay. Now let's look at different types of sensors. Again, a little in detail. So if I look at only temperature sensors, then there are different types of temperature sensors. Okay. There is a sensor called as thermocouple sensors. The reason why I put these slides is to make you just understand that how vast this field is now. Okay. So these sensors were already present. So what new has happened is, with these sensors, now there is an ability that they can transfer data real time from machine to machine. And that has completely changed the whole dynamics, right? So there's a thermocouple sensors. Typically, if you look at the AC temperature measuring. So these sensors are voltage devices that indicate your temperature measurement with a change in voltage. So if typically the temperature increases, the voltage also increases. Okay. So we all know those old formulas, right? Your V is equals to IR. Anybody remember these formulas? V is equals to IR. What is V is equals to IR? Let me ask this question. Yeah, somebody was saying V is equals to IR. Okay. So typically it works on a fundamental that, if the temperature increases, the voltage also increases, right? So these are thermocouple sensors. Then you have resistor temperature detectors, and these are typically a thin film which are made of platinum, and your resistance is directly proportional to temperature. That's another thing. So these are used in your coolant, the fire detectors, and so on. Then you have thermistors. It's again a temperature sensitive resistor that changes its physical resistance with the change in temperature, right? So these are different types of temperature sensors available. Then you have a semiconductor based sensors, and then you have infrared sensors, which again measures your temperature. And there are different technologies that are used in infrared sensors. It could be based on, so we saw this previous slide where these are based on transmissive type. It could be a reflective type. So that's how infrared sensors are, okay? Then we can look at proximity sensors. There are different types of proximity sensors like inductive sensors, capacitive, photoelectric sensor, ultrasound based sensors, right? So there are different use cases for all of these sensors, and based on your research area, you can decide which sensors to be used at that point of time, okay? Do you want me to go in detail or touch upon them and just move on? Any suggestion from the audience? Okay, fine, let me move on. I'll touch upon them and we'll move on. So then we also have pressure sensors. Yeah, please. Somebody was saying something. Okay. So then you have pressure sensors, typically used to measure pressure of gas or a liquid. They're used in weather monitoring. These are again low cost and small power consumption, small in sizes. They're different. Again, the pressure sensor could be of a different type. You have a manometer, you have a vacuum pressure, you have a seal pressure sensors, and so on. Then you have a water quality sensors, which measures the quality of water. And again, you can measure different properties of water, like what is the pH value, what is the level of dissolved oxygen, what is the oxidation reduction potential of water. So these are things that can be used, and you can monitor chlorine level, you can monitor other things, other properties of a water by using these sensors, right? Then you have a chemical sensors, typically used in a lot of chemical industries, okay? Then there are different types of gas sensors, which measures a particular gas, like carbon dioxide, like carbon monoxide, the methane that I just mentioned about in the mines. So these sensors, there are so many sensors, just that all of these sensors were already there. What new thing has happened is you have now attached an ability where the information from these sensors can be transferred real time, okay? So I will not go very much into detail about different sensors, okay? If you are interested, just we can touch upon. So there are a lot of sensors which are available for monitoring humidity, optical sensors, and so on. Now, before we move into the healthcare, I would request if you can play a short video which tells about how IoT is being used in healthcare. Shall I stop sharing my screen? Are you able to share that video?
Sir, I want to share the video.
Yeah, please share it now. From my end, I think
Okay,
the audio
sir,
will
okay.
not go.
Okay, sir. Okay, sir. Thank you.
Yeah. that video is not coming.
Together with our customers, we're driven to make healthcare better.
Ma'am, that video is
We
not
hold
coming. I
7700.
can only see your screen where these two downloads are there. I think you'll have to share another screen.
To patient.
Yes.
Stryker's mission is simple. Together with our customers, we're driven to make healthcare better.
We hold 7,700 patents on medical technology products. From surgical and endoscopic products to patient handling and orthopedics to neurotechnology and more.
Innovation has always been at the forefront of what we do. In our partnership with Microsoft, our work in the Internet of Things space has been a big boost for us.
Azure Cloud enables security and helps Stryker to connect to and have real-time data and access to performance data from those Stryker devices globally.
Historically, when we'd have access to a product, it was only during a service event. What the Internet of Things has allowed us to do is to really capture data continuously. Having access to the data allows us to more quickly respond to the needs of our products that are in the field to make those products better. And we see tremendous opportunity for a growing portfolio of devices.
But potentially even more exciting is the opportunity to put this data in the hands of our customers.
Smart equipment management is really device-derived data. What that means to our customers is an assistance with fleet management and predictive modeling.
The data allows us to predict any maintenance issue before it really happens. This is something that we've never had in our industry before.
For a typical biomed department that covers a large amount of medical devices, reducing downtime by even 1% can translate into significant cost savings.
Stryker's use of real-time data allows us, the end user, the physician, the surgeon, to better control the usage of instruments in the operating room.
They are definitely one of the most innovative companies in the industry. They're taking advantage of the complete platform, the Azure Cloud, the IoT, machine learning. That real-time data enables Stryker to improve healthcare as an endpoint.
Through our work with Microsoft, we're positioned to potentially transform healthcare in partnership with our customers. If we can tie clinical insights with some of the device insights and ultimately get to better patient outcomes, that's the holy grail.
By harvesting this data from these connected products, turning that data into information and sharing it back with our customers, both clinical and non-clinical, we feel that we can positively affect patient outcomes.
At the end of the day, we provide clinicians tools to provide better quality of life for more people, one product at a time.
Good. Thank you. So a quick question for everyone. So what is the takeaway from this video? What did you understand? Please use this chat window. What are the key takeaways from this video? What did you understand? Am I audible?
Yes, sir.
Yeah. Please, I'll give a few minutes. Let's spend a few minutes on this and then we'll move on. So what are the key takeaways? Did you look at some of the keywords like quality of life? He talked about quality of life. He talked about continuous monitoring. We talked about maintenance of device. Even if you are able to bring it down, the error rate by 1%, it would be very useful, right? Look at the number of patents that are there. 7,700 patents. That's a huge number. That too working in only in one of the industry, which is providing continuous monitoring, right? What are the other takeaway? Just think, what are the other takeaway from this video? How can we use it in our real life scenarios? Is anybody type? Okay. Yeah, Uday. Was to help people and improve on efficiency of the healthcare system. That's very good. Again, I'll go back to my previous example where I said that only 25% of the population gets 75% of the healthcare facility available, right? How can we use IoT now? Also, if you look at the current COVID situation, people ran out of beds. We did not had the devices available to oxygens. There was a scarcity or shortage of oxygen. Can we use IoT device and come up with a home care based monitoring of patient? Also during the COVID time, other patients who are suffering from, let's say, or who need to go for a kidney dialysis or are a heart patient, they cannot go to hospitals for their regular checkup. How can an IoT device help them so that they don't have to visit the hospitals very frequently? The doctor should also get all of these information real time, and it helps in decision making. Right? Let me ask you a question. How much time does a doctor spend when you go and visit the clinic, typically on per patient? Any random number? Let's say there is a cardiac patient and he or she need to go for regular checkup every 6 months or a year. How much time does a doctor spend? Any random number would be fine. Anyone? $20 to 30 minutes. Okay. Any other number? 30 minutes. Okay. It's still on the higher side. 20-30 minutes is very high. Yes, Uday, that's right. It's on a live data. So how the live data can help? So typically, let me tell you, if there is no problem, then typically a doctor spends less than 2 to 3 minutes on a patient. And I'm telling you from my own experience. And my mother went for a cardiac surgery. Now she's fine, but now when we go to visit the doctor every 6 months or a year's time, they spend 2 to 3 minutes, not more than 5 minutes, if everything is okay. If the vitals are okay, they will spend like 2-3 minutes. So that's a typical amount of time that a doctor spends. Now, if you're spending just less than 5 minutes for a doctor, it is very important that they get access to all of the historical data. And that is where IoT, artificial intelligence, machine learning, that can help. Right? So let's imagine that there is a very severe cardiac patient who has gone for an open heart surgery, and you need to continuously monitor the heart rate. Okay, in the initial days. What if I tell you that there are devices available which can be those, and those are called as a wearable device. You can wear it like a necklace. You can wear it like other types of ornaments, and that will monitor your heart rate on a regular basis. So before the patient goes to the doctor will have a complete report of how the heart rate is working during the day, during the afternoon, during the night, during the time when he's doing exercise, during the time when he's sitting idle. How is the heart rate changing? Now that will help the doctor to take decisions a lot more faster. And that is also one of the way, by using IoT, you can reduce the gap between the doctor and the patient. I think in India, it is 1 doctor per 1,000 patients. right? So that can also be reduced by using IoT devices, right? And Uday, to your question, yes, they talked about live data, and that's where live data is very useful. Okay, let me give you an example. In babies, we were monitoring the heart rate, and in one of the scenarios where the ECG, everything was coming normal, and this example is from India itself. Okay, everything was coming as normal, but somehow, doctors were not able to diagnose what is the problem with this child. And that is where we used our device, and we continuously monitor the heart rate of the child. And during the night, we found that there is a certain interval when there is a drop in the heart rate. And that is something which we monitored for a long period of a time. And then we reported to the doctor saying that, this is a time when the heart rate is going down. And based on that, the doctors were able to take a decision that, yes, it need to go for a heart surgery. Okay. Yes, Priya, it is very much possible. See, IoT is all about capturing data. Okay. Now, once you have captured the data, then there are two technologies that are being used. One is a big data, where these informations are stored and processed. What do you process? Then you use different algorithms. And that's where your machine learning, artificial intelligence, deep learning, all of that come into the picture. Yes, Ramesh, that's right. Machine learning based concept is certainly being used in analyzing the data from IoT. That's right. Thank you. Okay. So IoT is all about continuously capturing the data. The next step is all about analytics. It's all about doing prediction, right? So if you have these devices, right, you can also predict whether the patient will go for a hospitalization or not. Let me again go back to the heart monitoring device. Let us say I have put those devices in critical patients. Based on the changing heart rate or a drop in a heart rate, you can predict whether this patient would require hospitalization or not. Okay. So those predictions are then done by using machine learning based algorithms. Typically, you can use a classifier, which can classify based on different parameters, whether this patient would require hospitalization or not. And there are multiple algorithms which can do that. For example, support vector machine, you can use a naive-based classifier, you can use a decision tree, ensemble-based technique, so on. There are multiple such kind of algorithms available. Okay. Any more question on this? Any input? Okay. How's IoT in healthcare safe? Okay. What are the safety measures taken? Exactly. So that is where we talked about different mode of communication. And yes, there are a lot of research that is being done to make these IoT or communication in general as safe, right? So security and cloud is another area which has emerged because of IoT and AI. There's a lot of work that has been done. Thank you, Sayed, for your question. Okay. Let me share my screen and we'll move on. So I think we have addressed this question. Why IoT is required in healthcare? Any other opinion why it is required? Yeah, as we talked about, there is a shortage. There is a gap between the number of doctors and the number of patients we have. That's why we need IoT based devices. The second one is we also need continuous monitoring, right? So if you go to the doctors right now, they will only do a treatment for the symptoms. They don't do a root cause analysis, right? And that is where your IoT based devices can be used for analyzing the root cause. The example that we gave, or I gave, about a child who had a heart rate problem. So you can do a root cause analysis that, why this is happening. And that's where, correlation from data from multiple sources would become very important. It's not only capturing from a heartbeat monitoring device. You also need to look at what is the kind of activity that person is doing at that point of time. Is that the activity which is causing the problem, right? Or you can look at the habit of a person, right? Is that a time when he is smoking? Or typically you can analyze that during the Fridays. And there was one prediction that I had done on the healthcare data where we had predicted that on a certain day the hospitalization might increase. And this was done for one of the US hospital in that area, where we analyzed that on a particular date the hospitalization might increase. And based on that, we were doing a workforce management, that we might need more doctors, we might need more beds, and so on. Okay. So a big advantage of using IoT devices is for continuous monitoring, right? And then prediction and taking action on them, right? So just to brief, a quick point, why IoT is required in healthcare. So we need to turn data into action. Right now, we have got a lot of IoT-based devices. It has also become a fashion that you are wearing a necklace, which is also monitoring your heart rate. You're wearing a band, which is monitoring your heart rate, right? Now we need to convert this data into an action. So let us say there is a diabetic patient, and the doctors have said that on a daily basis, you need to exercise for 30 minutes at least, or an hour. So you have to typically run for 30 minutes. Now, by using a Fitbit-based devices, we can then monitor and say that whether this patient is following the opinion that is given by doctor or not, right? Otherwise, there is a old saying in medical fraternity that every patient lies. If you guys would have seen there's a series called as Dr. House, right? If you watch those Amazon Prime series, the Dr. House says that every patient lies. So that's where your IoT-based devices can be used to know whether the patient follows the guideline or not, right? IoT devices are also used to improve the patient health. So you can continuously monitor the blood sugar and say that this is a time where you can stop. And there are other devices also that we built, not typically an IoT-based devices. As I said, it's a complete ecosystem which requires machine learning, deep learning, AI, and everything. So we had built up a application where a diabetic patient, and we propose it for a diabetic patient. So they can go to a store, they can scan whatever they have bought, and then the application will tell you whether you have to buy this or not, and this is good for your health or not. So the whole ecosystem can be used to improve patient health. The third one is it is used for a better preventive care. So before this particular thing happens, or cardiac arrest happen, you can prevent it, right? And let me give an example where I used it on my mother. Okay. Few years back, my mother had reported some problem with her blood pressure, and she was taking blood pressure medicine from like some 10-15 years. Everything was fine, but we noticed a peculiar thing, that even if she takes a blood pressure medicine, her heart rate used to be still, the blood pressure used to be 180, which is very high after taking blood pressure medicine. So what I did was, we used our devices from the company. I had taken a request from my manager, and we took that device, and it's a 3 diode based device, which I had put it on my mother. And for the whole night, for a couple of days, my friends, my doctor's friends, they monitored my mother's heart rate. And they said that, a certain time during the night, there is a ventricular event that is happening. So, and then they said that maybe there is a problem in the left ventricular arteries. So after that, I took my mom to a hospital. There's a hospital called Sakra Hospital here in Bangalore. And we went for an angiogram and we found that there is a blockage. There's a big blockage in the main artery. So you can prevent, a heart attack, and we actually prevented it. And my mother is absolutely fine now, and things like that. So this is where your IoT devices can be used to prevent things, right? There's another example where we use a real-time remote monitoring. So I don't know how many people know there are certain Naxalite areas in India where people are not allowed to go. Forget about hospitals here. Even the local politicians don't go there. So there's one such kind of an area in Andhra Pradesh where we had monitored. We took a help of an ASHA worker, and there was a high risk pregnancy case where we had used our device for fetal monitoring, and we kind of detected what is the problem with that pregnant lady by using that. So that's a real-time remote monitoring devices. That's where IoT can be used, right? And there are many other examples where the doctors said that it is very hard, very difficult to save the child or the mother. And in that case, we were able to save both mother and the child. And this is one use case in Bangalore where there was a high-risk pregnancy case of a lady who hailed from West Bengal, and we were able to save their life by using real-time remote monitoring. So another important advantage of using IoT again is, the patients and their family members are more informed. They know what is right for their parents or for their patient, so they're more informed, right? And there is also an increase in patient satisfaction. That is what we have seen. And there was a use case that was again for a cardiac patient here in Bangalore, multiple patients who feel more satisfied because they are more informed, and they know that if there is a problem that happens over a night, we have certain devices which can raise an alarm and say whether the hospitalization is required or not. Okay. Another reason why we need IoT in healthcare that we talked about is again because of lack of skilled labor in rural India. That's where, so just think about a case where you have a patient out there in Northeast and you don't have a cardiac hospitals available. Then you can continuously monitor, and the right time you can say that this patient requires hospitalization or not. So you don't have to travel all the way to the hospital. And typically in India, people tends to ignore. They have a chalta hai attitude, right? So it's fine. So we can manage. But by using certain devices, now you can say that now this is a time when you cannot, manage. It is time you have to go for a hospitalization, right? Any comment, on this? Any other ideas that you guys have? Let's take a pause for a minute. You can use the chat window. So how is it? Is it sounding interesting or it's boring? How it is? Quick audience poll. Any other idea where else you can use IoT in healthcare? Okay, let's move on. Now, let's look at healthcare, IoT in healthcare from a different angle. So that will also help people to come up with innovative ideas, right? So if you put yourself into the shoes of a patient, right? So there are certain needs that are needs of a patient. Then you can think of IoT from a physician's perspective. We talked about different examples where based on the data, the doctors already know what is going wrong with this patient, right? Then you think from a hospital's perspective. Now, another example is nowadays, if you go to a big hospital, your vitals are not measured by by the doctors. So you have a nurse who would measure your weight, they will measure your pulse rate, they'll measure your blood pressure, all of that. Okay, so that is where you are able to save the important time of a doctor. So from a hospital's perspective, that's where your IoT is used. In fact, I was working with one of the hospital, and this is again an example in India itself, where we are talking about a smart hospital. So the moment a patient walks in, so he's walking through a room, and that's where by using a lot of sensors, you can capture the parameters, the vitals, and directly the patient will go to the doctor and he will have all of these parameters on his screen. Right. So now you don't need to sit in a queue where there is a nurse who would come and measure all of these vitals. So from an IoT, from a hospital's perspective, again, IoT is very important, right? From an insurance perspective, now the first time when these Fitbit devices had come, we thought that it would be the hospitals who would be selling it. And I was working with one of the insurance company in US, where we thought that the hospitals would be the one who would buy these devices, and they would in fact they would insist the patient to buy these devices and then monitor the patient's real time. But it was the other way around. It was the insurance company which were able to sell these devices, because now they are linking the insurance amount with your vitals. So if you're a diabetic and if you're not following the guideline, then the insurance company would increase your insurance amount. So the IoT can also be used from the insurance company's perspective, right? So you have a patient view, you have a physician view, then you have a hospital and an insurance view, right? So now when you're coming up with certain innovation and research in these areas, you can start thinking from all of these different perspectives. Okay, so these are, again, it's as I started earlier, innovation is all about finding answers to the relevant questions. So again, you have different questions here. So what kind of a care can be given to a patient? Okay, how information is made available to physician? If you're thinking from a physician side, how can it help hospital to target healthcare in totality, right? And from a patient's perspective, or from a insurance perspective, how can you link patient, hospital, and insurance all together, right? So there are different ways, different perspective from which you can think about IoT in healthcare. Okay, any questions here? Anytime, if you guys have any question, you can always post. I'll be checking in between. Okay. Now, again, there are certain other advantages. Your IoT can be used to reduce the cost. Okay, there's a cost reduction. It helps in a better treatment of a patient. Then there is a fast disease diagnosis. As I mentioned about a child, we were able to diagnose that there is a problem and it requires a pacemaker much more faster. So it helps in fast disease diagnosis. Then there's a proactive treatment. The example that we talked about, where when the hospitalization is required, that's a proactive treatment, right? Then there's another problem that we tend to ignore in all of these healthcare. So other than the doctor, patient, and nurse and hospital, there's one more thing which is lost and it is ignored. Those are your consumables. Those are your devices. How frequently does these device goes for a maintenance? And that is where your data that is captured from these devices can be analyzed, and you can say that maybe this device requires a maintenance, right? And there was a use case that I was working, not from a healthcare, but from other industry, where we were analyzing the data from one of the company in Japan, and then we were able to predict that these hard drives might require a change. They are reaching an end of a life because of XYZ reasons, and this is a time when you need to change your hard drive. So on a similar lines, you can analyze these devices and say whether it requires maintenance or not, right? This will also reduce error reduction. We saw that video where they mentioned about error reduction by 1%. That itself is a big number, right? And there are many examples, not necessarily in IoT, but typically look at cancers. So you can detect from a historical data whether this is malignant or this is benign. So by using machine learning and AI, you can reduce this error to a large extent. Okay. So these are certain advantages of using IoT in healthcare. Now let's talk about, again, we talked about these things, remote patient care monitoring. This is another use case in IoT. Your emergency care, we'll look at one of the example in emergency care. I think in 2018, what had happened was there was an accident which happened in Bangalore. Okay. And there was a patient there from Jharkhand who was treated, I think, in Calcutta. So he required a heart. So in Bangalore, there's an accident which happened, and it has come in the news, where the heart from Bangalore was transferred all the way to Calcutta, and it was planted in that patient. Although this was done using without IoT, but think about a smart city where you have a lot of these IoT-based devices which can monitor your traffic signal, which can monitor, other things on the airport, and then the communication or communication can happen between two different cities and can be certainly used for emergency care. Another use case is again on tracking of inventory, staff in a patient. This was a use case which I had done for one of the hospital in US, which I talked about, where we were able to predict whether there would be more number of hospitalization that is going to come this week or not on a certain day. Okay, we can also monitor the inventories. So we can say whether there's a shortage of a drug or a shortage of certain equipments in your lab and so on. Then there's another area which is coming up, which is based on augmented surgeries. It is still in talks. Where the machines can do the surgery by themselves. Not very popular, but this is another area of research. Okay. And then you have virtual monitoring of critical hardware that we just talked about, where you can monitor whether those devices would require maintenance or not. Okay. IoT can also be used for a pharmacy management and again for wearable devices. A lot of wearable devices, right? So we have talked about this remote patient care monitoring, and I think, how much time do I have, madam? I have few more slides to cover.
Yes, sir.
Yeah.
So 15 minutes more, sir.
Or 15 minutes more. Okay.
Yes,
so
sir.
then these are use cases in remote patient care. Okay. I will jump to a data. This was an example where the heart transplant happened in a patient. His name is Dilchand. He's 39 years old from Jharkhand, and he received a heart harvested from a youth who was declared brain dead in Bangalore. And this is a news from, actually, this happened in May, not May 19. I think it's from 18. Okay, so that's where you can think of a better smart city where IoT can be used in synchronizing with ambulance, road traffic, and hospitals and so on. Okay, so typically we talked about analytics during this, and these are old numbers, but it is expected to increase by more than 4%, 6.40%. Okay. So far. This is not a real-time monitoring. Okay. So let me quickly jump into an example. Let me stop sharing. Okay. How do you? Let me share another data, and that would help you to analyze. Okay. Are you guys able to see my screen?
Yes, sir.
This is not the example. Give me a sec. This is not the example. I think it opened another sheet. Yeah, this is the data. Are you able to see my screen now?
Yes, sir. Yes, sir.
Okay, great. So this is the data that I have taken again from an open source. Okay, so this is about a patient who is using a Fitbit device, and on 25th of March 2016, he walked 11,004 number of steps, right? So based on that, what we have, and typically you have these devices, you don't have to even use a Fitbit device. This data is from Fitbit, but you can even use your mobile app, and you can track the number of steps that you're walking on a daily basis. Okay. Now this is about a patient. So there are like some 457 records where we have the daily number of steps that the patient walked. So typically he walked 7.1 kilometers, and then what were the typical kind of activity that he did, whether he was walking slow, so that you can monitor, right? So based on the number of steps that he's taking in an hour, you can measure whether it's an active, the person was very active, or it's a moderate walking, or it's a light walking, or he was in a sitting position, and so on, right? So we have this data. Now I would like to open it up for everyone and just have a look at this data, and you can quickly tell me what you can do out of this data. Is the question clear to everyone? Is this question clear? So this is a data that is being captured from Fitbit device. So you know the number of steps that the person is walking on a daily basis, right? What can you do out of this data? Let me see the chat window. Yeah. Let's take a pause for a minute. See what all you can do out of this data, and then I'll show you the example. Or quickly, you can write anything that is coming to your mind. So you know the total number of steps that the person walked in a day, right? How many kilometers he has walked. Now, what can you do out of this data? Do you want to give a try, or you want me to? Let me call out names. Okay. Very good. See it. I was about to call your name. Good that you responded. So a layout of live data. Very nice. We can find if the person is healthy or not. Very good. Okay. What else? Like all other names. Okay. Can I see all the participants? Harshini, would you like to give a try? John, would you like to give a try? What can be done on this data? Sita. Cholesterol level, very good. You are connecting it to the diabetic patient. Very good. I like the thought process. Sita, John, and you have Shiva. I'm just calling out some random names. Vignesh. Wanna give a try? So there's no right or wrong answers, right? So anyone else? Good. Now let me connect the dots. So Sayed said that we can find if the patient is healthy or not. Very good. Yes, we can. So typically, let us say we say that you need to burn close to 1,000 calories or 2,000 calories. Just a random number, 2,000 calories in a day. And we can come to know whether the patient, when the person is, is health conscious or not. So that's number one, based on the number of calories that he's burning. And this is only based on your walking data. The second one is layout of live data. Very good. This is a very good point that you have made today. So you can typically understand the profile of a patient based on this, or a person based on this. So typically you'll notice that it is over the weekend that the person does a lot of exercise. During the weekdays, he is more in a sitting position, he's doing that kind of work, but over the weekend he's very active. So you can understand the layout of the data, right? Harshini mentioned about cholesterol. Very good. If I say that this data is of a diabetic patient, okay, or he has a high level of cholesterol and triglyceride. So by using the amount of calories that he's burning in a day, you can say whether the patient is following the guideline that's given by the doctors or not, right? Very good insight, guys, right? Now this, what about connecting the data with other information? What if I tell you that this patient, so you are connecting this data with your healthcare data. You are connecting this with LIS. LIS typically lab care information system, laboratory information system. So you are connecting the data with the lab parameters. And then you can say whether the patient is keeping a good check on his sugar level or not, right? If a patient is overweight, then is the amount of calories that he's burning in a day sufficient for him to lose the target weight of, let's say, 15 kilograms that he want to lose in a period of 3 months? Is he going to reach that target or not? So by connecting this data, you can send reminders to the patient. You can encourage patients to do more exercise, right? Now let me show you what are the analysis, initial level of analysis that you need to do on any data that you get, right? So let me share back my PPT. Yeah. So this is typically the data that we saw. Okay. So these are nothing but the description of the data, where this data is captured from Fitbit, and this code, this is again freely available example that you get it from Kaggle. So this is 1 year of Fitbit charge heart rate data. Okay, this is how the data looks like. You have number of calories that he has burned, number of steps that he has taken, distance, the minutes of sitting position, slow activity, moderate activity, and so on. So before you jump into machine learning and doing AI, you first need to analyze the data. You see how many minutes he has walked and so on. And then you can analyze the data by using certain graphs. Okay, let us say I want to analyze. So you can plot the data, right? Saying that, so you can analyze the data saying that how many calories he's burning over a period of time. Okay, you can analyze and say that, what typically the distribution looks like. So you can analyze saying that on daily basis is burning this much of calorie, but maybe over the weekend, maybe he's in a party mode and that's when he's not doing the exercise, right? So all of this kind of analysis can be done on this data. Okay. This is about intense activity. How much of intense activity he has done? Okay, is it on the higher side, mostly for this patient, I see that it is between 3.5, or it is between 2.75 to 3.75. This is where he's burning, he's doing the intense activity, right? Similarly, you can analyze, you know, fair activity, the number of minutes that he has done, and so on. Okay. Any questions on this? Any other ideas? Okay. So as I earlier mentioned, IoT is all about capturing the data. On top of that, you need to do some analysis. The first step, or the first type of analysis that we do, is on a statistical it's a statistical analysis, where we would look at the distribution of data and so on. Based on that, also you can draw a lot of conclusion. The second level of analysis is more deep. It requires AI, it requires machine learning, it requires deep learning at times. And it also, the next level is also about, collecting data from multiple sources and, drawing meaning out of them. So you can look at these devices, you can look at HIS data, you can look at LIS data, you can look at other type of a data, and then try to, connect the dots and find out a meaningful information out of it. Okay. Now, coming down to the latest research that are being done, right? Some of these research are very recent. For example, I've taken from COVID-19 case. So just a sec, is there any chat message? Okay, nothing here. Okay. So you can analyze. So this is one paper that was published in 2020. Okay, they have come up with a model for effective COVID-19 identification and uncertainty environment using a primary symptoms and CT scans, right? This is one area where IoT can be used. So here the IoT devices can help monitor the spread of COVID-19. They have come up with they have proposed a model to differentiate between a COVID-19 other types of chest disease. So in COVID-19 also you have a breathing related problem, you have a chest congestion. So how do you differentiate between a normal chest congestion and COVID-19 kind of a chest congestion? So that is again done by capturing information from, so they have proposed a methodology that can be used to differentiate between other types of chest diseases. Okay. They have used a wearable device to monitor the spread of COVID-19. And see, another thing is you can use a drone. Now, there are many areas in India, right, where it is very difficult. And as I said, we have a large population, but we don't have that much of manpower to monitor it. So you can use drones and you can see whether people are following the social distancing measures or not, right? So that's where your IoT-based devices can be helped, can be useful. The another one is again, it's based on they have proposed a different kind of a communication channel where they have come up with a wireless body area network, and that can be used in IoT connected healthcare. So this can be used for a smart hospital. So there's another area, right? Then there are other areas where they're working on secure medical data transmission model for IoT-based healthcare system, right? So they have come up with a hybrid security model to secure data. So I think somebody talked about a security. So this is one paper, relevant paper, which was published in 2018 in IEEE conference. IEEE access, and here they have used a hybrid security model to secure data that is getting transferred in IoT based devices. Okay, and typically if you go through this research paper, it is built using a wavelet technique, and they do an encryption of a data while doing a transfer. Okay, and they also hide a certain amount of confidential data. And I remember when I was first analyzing the SpO2 device, we were not able to capture the information. We realized that they are hiding the information. They are broadcasting it. There is no security at all, but they're hiding the important information in a bigger packet. So they have used a similar kind of a technique for IoT based healthcare. Okay. Any questions so far? There are other, again, research area that you can take it up. Okay. There's again on fighting the pandemic. And the another very, very interesting research paper which was published. Are you able to see my screen? I've changed the tab. Are you able to see it? Anyone? Are you able to see it?
Yes, sir.
Yes. Okay, great. So this is where the IoT is going to become very popular because of your 5G. Because now by using a 5G based technology, you can continuously transfer data on a real time. Just think about the house which is completely connected. You have a fan, you have a tube light, you have all the other equipments in the house which are connected, and that's where you need a 5G based technology. It's again a very interesting research paper. Go through this. Okay. Any questions so far on this? Okay.
Sir,
Yeah.
there's a question from the participant.
Yeah.
We can use ML for.
Yes, we can. Yes, we can. Yes, Sayed, that's right. Raspberry Pi and Arduino, they are very helpful in your IoT based devices. In fact, we had just for a gaming purpose, we had constructed a small data center by using this. Now, getting down to the previous question about using machine learning. Now, let us say the Fitbit data that I just showed. Let us say instead of one patient, I have it for multiple patients. Okay. You can then use unsupervised. Let us say I'm using an unsupervised based technique, and I want to analyze the clusters. I want to see, let us say I can classify the people here in Chennai, in Bangalore, and say that, we can then say that typically in this cluster of people who are in Chennai, they are more active as compared to another cluster which is in other part of the country, right? So that kind of a cluster-based analysis can be done. So that's one example where machine learning can be used. You can then also classify the data, the prediction that I talked about, there by using their IoT based data captured from different sensors. You can predict whether the patient will go for a hospitalization or not. And that is where you use classification techniques. And there are a lot of classification based techniques, right? Very simple algorithms like support vector machine can be used. Your naive Bayes classifier can be used, right? Although, nowadays deep learning has become very popular, but I can share examples where I have analyzed terabytes of data, 2.5 terabytes of data per day. And there we used algorithms like naive Bayes classifier, we used those kind of techniques. Any further questions, guys? We are almost at the end of the presentation, so just take a pause for a minute and open up for questions. You can use the chat window.
Participants, if you do have any questions, kindly do post them in the chat boxes. They will be addressed in a moment.
Any other suggestion, any thought? I know somebody talked about machine learning. Any other thought on how we can use this data, machine learning, deep learning, and analyze? How many of you guys are learning Python and machine learning as a part of your curriculum? Is it a part of curriculum, ma'am?
Final year students, they are learning Python, sir.
Okay, great. Yeah, Python is a very popular language, which is nowadays being used. Okay, fine. So if you don't have any further questions, then, thanks a lot, guys, for thanks a lot, SRM University, for giving this opportunity to come and talk about it. And I hope this session was very helpful for the people. I'm open for suggestions and feedback. Yeah, thank you.
Thank you, sir.
Yeah, over to you, ma'am. Thank you.
Why IoT in healthcare? Where is the need for IoT devices? What could be the benefit in using an IoT device? How is the information made available? These questions may sound basic, but this is where the journey to meet our needs begins. From a traffic signal to preventing heart attacks, IoT is definitely a way to a better, safer, and healthier future. Thank you, sir, so much for sharing on the importance of IoT and its need in healthcare. I once again thank you, sir, for that awe-inspiring speech.
Yeah, thank you.
No duty is more urgent than that of returning thanks. To conduct a webinar of this magnitude is no easy task. To honor and respect those who made this event a grand success, may I request Mrs. R. Priya, Assistant Professor, Department of Computer Science, BSc, to render the vote of thanks.
I am honored and delighted to take this opportunity to thank the gathering on this special day. I must mention our deep sense of appreciation to our guest, Mr. Abhishek Gunjan, AI Principal Scientist, Accenture Operations, Bangalore, for sharing his knowledge about IoT in healthcare system and also explained how to predict heart disease using IoT. I also extend my sincere thanks to the management for encouraging us to conduct this one-day webinar. I also wish to express my gratitude to our principal SNH. I render my special thanks to our VP Academics, VP Admin, and our beloved HOD for their consistent support. I would like to thank all the participants who showed very much interest in this program. Finally, I thank our faculty members for their kind cooperation and support. Thank you all. Hello. The feedback link is posted in the chat box. Kindly fill the feedback form.
Thank you, Abhishek, sir. Thank you so much.
Thank you, ma'am. Thank you so much once again. Bye.
Thank you, sir. Thank you so much.
Participants, kindly fill the feedback form.
The feedback form is posted in the chat box. Kindly fill the feedback form.
Posted in the live also, ma'am.
Yes, ma'am. Yes, ma'am. Posted, ma'am.
So those who are participating in YouTube live, so the feedback link is posted. Kindly fill the feedback form.
பிரியா மேம், கனிமொழி மேம் கம்ப்ளீட் பண்ணிட்டீங்கன்னா ஒரு நிமிஷம் கீழே வாங்க.
Yes, ma'am. Yes, ma'am.
ஓகே.